Look at this diagram of system requirements collected during stakeholder interviews. We have hundreds of raw demands, and right away there are logical contradictions, like one rule stating patients see all reports, while another states patients see none. If developers start writing code based on this unprocessed list, the software will fail. You cannot program a feature when the instructions tell you to execute two mutually exclusive actions. Before writing a single line of code, the development team has to filter, resolve, and organize this raw data. This rigorous step-by-step process is called requirement analysis. This directed graph defines the baseline difference. Requirement gathering is simply the node where you collect the data. Requirement analysis is the subsequent node, where you understand and verify that data. Raw, unprocessed data is a liability to a software project. It must be analytically verified before it becomes an asset. This flowchart illustrates the requirement analysis pipeline. It takes raw input and pushes it through 5 distinct operations: collect, analyze, prioritize, resolve, and validate. First, we analyze. If a user requests a login feature, the developers have to nail down the specifics. Does the system authenticate using an email, a biometric fingerprint, or a Google account? The ambiguity is removed here. Next, we prioritize. For a food delivery app, logging in and processing payments are core essential functions. Custom UI themes and dark mode are optional enhancements. The essential features are scheduled first. Then, we resolve conflicts. If a company manager wants employees to edit their own salary data, but HR insists only HR should have that access, the development team must mediate with stakeholders to establish a single operational truth. Together, these sequential steps function as an algorithm, converting subjective human desires into strict, non-contradictory rules. The final check in this pipeline is validation. This ensures a requirement can actually be quantified and tested by a system or QA engineer. This text input shows a common failure. The software should be very secure. That gets flagged with a not measurable error because adjectives like very are subjective. The verified output replaces it with hard, testable rules. The password must be greater than or equal to 8 characters, with at least 1 uppercase letter and 1 number. Try applying this rule yourself. Pause the video and figure out how you would rewrite the ambiguous requirement. The software should load quickly into a measurable, testable metric. Here's the validated requirement. We replace the subjective phrase "load quickly" with a mathematical logic statement. System response time must be less than 2.0 seconds. The rule here is absolute. If a requirement cannot be quantitatively tested, it is not a valid software requirement. Once the analysis pipeline is complete, all the approved requirements are compiled into a formal deliverable called the Software Requirements Specification, or SRS. Looking at this JSON structure for a library management system, you can see how an SRS separates information. It isolates functional requirements, the specific actions the system performs, like student login, from non-functional requirements, which are the system constraints, like ensuring the response time stays under 2 seconds. A high-quality SRS must consistently hit 5 criteria. The document must be correct, complete, clear, consistent, and verifiable. You can think of the SRS as the physical architectural blueprint for the software. It provides a single source of truth so that the designers, programmers, and testers are all working toward the exact same specifications. To eliminate any confusion between these terms, look at this comparison matrix. Requirement analysis is the process you conduct. The SRS is the document you produce. A finalized SRS means the team has successfully defined exactly what the system must do. With that foundation set, engineers can move into the design phase and figure out how to build it.